This is my latest purchase. It's too big to fit on the bench in one piece. Well, in fact it's too big to fit on the floor in one piece. But luckily it breaks down into two pieces like that. As usual with things I buy, it doesn't work. Now you'll only be able to see parts of this on the bench at any one time, because clearly it's too big to fit on the bench even as a half-size object. It's a hedge trimmer from Bosch, 18 volt. See more details when we get a little bit closer to it on the bench. As I said, you can't see all of it now. You just about see the handle here. Bosch Universal Hedge Pole 18. So 18 volt hedge pole trimmer. Here's the blade at this end. It's got a cover on it, but there it is. Now this bit might be working, it might not be, we don't know because the whole thing doesn't work. Now if we press that in there and we lift this up, I think that's that's about as far as it goes. But at this end I've already worked out which is which. You possibly can't see, there's a tiny little plus sign there. It's hard to see, so I've marked it with a red pen. So that will give us plus and minus. So if we put plus and minus from an 18 volt battery onto here, we will know if this bit works. So that's what we'll do. I'll leave the cover on it and we'll put a battery there and see if the motor runs. Right, you might not see this because we're off. I thought you might want to see the power going on. This is plus over this side, which is a pain in the backside, so I've got to swap these round here to get them onto here. But if the motor is working okay, obviously you will hear it because it won't be quiet. So there. So it doesn't look as if we've got anything wrong with the motor. So the fault of it not running is somewhere else, presumably the other end. So presumably the power can't get from this bit along the pole into the other bit. Now we could try continuity testing, or we could just try putting a battery on here and then looking at wherever these go. Somewhere along here must be a... oh, it's down inside there. That's going to be a pain, isn't it? So, in there. Maybe we do want to do continuity then, because I don't fancy trying to test voltage down inside there. Well, I might be able to do it, but the probes are going to be too fat to fit, I'm sure they are. Let me just have a quick test, but I've got a feeling we're going to have a job getting two probes in here. Yeah, look, they're not going to fit. Well, we'll have to find some way of getting some thin probes down inside there. Right, you won't be able to see in there because I can't see in there, but I think that one is tucked into where the minus would be, and I think if I push that one in now, that's tucked in where plus would be. Right, to save any confusion, I've got an almost fully charged battery here. I suppose it is fully charged, and if I go on there, you can see, whoops, come on, what's the matter with you? So you can see we've got exactly 20 volts. So we've got exactly 20 volts on that battery. I'll put this on that You might have heard the click as it went on. Now I'm going to pull the trigger. You watch that and see what that does. So according to that, we've got 14.4 volts. Release the trigger. Press the trigger again. 14.4 volts. Now I would have thought that 14.4 volts would be enough to make something work. But when I tried it with the head on it, it wouldn't work. But I guess we better try that again just in case, because maybe it's magically half fixed itself. Right, well there it is attached. Battery's on the end. I'll go down to the other end and press the switch. Oh, I don't believe it. It's fixed itself. Okay, it's next day and I've recovered from my laughing yesterday of this apparently fixing itself. Now, obviously it hasn't actually fixed itself, even though we saw it running, because I've just connected it back up again just to confirm what we saw yesterday. You can't quite see because obviously it's at the other end of the bench, it's down there, but if I pull the handle and click it, there we go, 14.4 volts, or 14.5 if you like. But the point is we've got a 20 volt battery on there. We measured the voltage, so this is just not right. So although it apparently fixed itself in the sense that the motor suddenly does run, whereas before when it arrived, when I bought it, it wasn't working at all. I can assure you that it just wasn't working. But now it is working, so whatever the fault is, I wonder if it is electronic, because A, it seems to have miraculously fixed itself, and B, there is something odd about this voltage, because why would we have 14.5 volts instead of 20 volts? Answers on a postcard. So I think we need to have a look at the switch end. Right, so here we are at the switch end. Battery's still on it, so I'll just pull the battery off because we don't want that at the moment. Look like they're all PH2s. Oh, that's quite tight as well. 1, 2, maybe I need to move this up a bit. What am I on? Oh, not too bad a setting. Oh, a bit more then. 3, 4, 5, 6, certainly a lot of these. 7, 8. So that's 1, 2, 3, 4, 5, 6. This one's being stroppy. 7. What about this one? I mean, I'm a real tuber, real YouTuber, you know, taking things out with tweezers. I've seen this all the time on YouTube. Right, is that it? What's anything stopping us coming apart? Springs, probably. That's what always worries me the most. I've had a few things where I've taken these apart and springs have shot across the room. Right, well that's come off nice and easy, so we'll get that out of the way. Oh yeah, and of course there has to be springs, doesn't there? Look, that's sprung loaded up into there, so that's our sort of, I suppose you'd call it an interlock, so that we don't start it up without pushing that out of the way. And then we've got a spring under there for the trigger, and it looks like we're triggering two things at once, doesn't it? Look. Trigger switch there, trigger switch here. Are they working at different times? Oh, it's difficult to tell. That one is touching before that one. but they could be actually triggering at the same time. I don't really know for sure. Now I mean it could be a problem with the switch, but I don't really see why it should be a problem with the switch. But as usual with anything electric these days, you just get all this nonsense, like a miniature blooming computer. I mean, look at this. So you can bet your life. Oh, that's strange. There's something. Can't tell if that's an oily residue or if that's just. I don't know. I don't know what that is. I don't think it's damp, but there's. There's definitely something there. So it looks like we're triggering two lines at once, doesn't it? Because we've got two lots of switches. So let's see if we can lift this out a bit. Spring, is that? Oh, that's going to stay there. That's a bit of luck. Right. So we're triggering the power, but we've got an extra white wire. And we're also triggering with this something else. Great. So we've got two different lots of triggering going on at the same time. And this looks like it's got 4 MOSFETs on it. So what's the betting? That there's some little brain in here that works out whether we should be turning on or not turning on, and then switches these MOSFETs to turn on. Don't think there's anything on here that helps us. But it actually says HW1V00, so that could be hardware, and then it says SW, which could be software, 0V31. I mean, it's just hard to believe. So this could have some sort of hardware number and then a software number, so it might actually be programmed. The world is just becoming insane. I'm going to see if I can get these wires off that disappear into the handlebar, because then we can just play around with the trigger mechanism without having all this. But these little, I hate these things. You only ever see them on stuff. Well, mind you, I suppose it's all Japanese, all Chinese, isn't it? I was going to say you only see them on Chinese stuff, but I guess you see them on everything because everything's made in China. And that come out? No, it's still not squashed enough. That's it. Right, so that's those little covers off, but I don't think we've got any chance of unsqueezing that. It's funny, the professional ones that do this, they do such a good job. My do-it-yourself version that I bought from China will not do that as well as that. Let's see if we can cut it in any way, but it probably won't do me cutters any good. Just depends, is that a piece of copper or something else that they've squeezed it with? Because I don't want to just cut the wires, because that will make them that much shorter, which might, in the long run, might not make any difference. But it's a bit late after the event, though, if you discover that making them shorter has made a difference. I'm trying to be careful here, because the other day I managed to do this and stab myself in the finger, and I'm still suffering from that a little bit. But at least I'm not having to wear a glove anymore. So, yeah, I think that might well do it. You don't want to sit and watch me do this, but I'll keep poking and pulling at this till I get them off. I thought you just might want to see how it does it. It's sort of unpeeled it, so you can. There it goes, and so that's the thing that they crimped on it. So that's that one off. So we've got white and red. So for some reason, plus from the board I presume is red, and then it becomes white, and black just is black and black. Right, so there you have it, there's our wires disconnected. So red to white, black to black, and now these just all follow around here. Might be worth remembering that blue is above red and then the small ones go below there. Oh, that goes all the way around the outside here. Now we can lift that entire thing out, and then we don't have to worry about this bit. This isn't actually held in with anything, but the wire is. I haven't got an 18 volt bulb, I've only got a 12 volt bulb, so not sure what's going to happen as a result of this. But if we try and get this on here, presumably that would have gone on that way round. That seems to be on. Now what happens if we press one of these? Nothing. Another one, nothing. What if we press both? Bulb comes on. And presumably that's only about 14 volts, because that's what we found before, wasn't it? So let's see what's going on. So we'll put that on volts. This might be the wrong way around, of course, because the bulb doesn't care which is plus and which is minus. Hopefully you can still see that. Right, I'll press them both. Now we've got 13.5 volts. But we've got an 18 volt battery which we know is charged to 20 volts. So everything is working except it's not, because clearly we're getting the wrong voltage out of this. Now whenever I get the wrong voltage, it's usually something to do with MOSFETs. So I think what we need to do is see if we can find a way of checking the MOSFETs. I've stuck a lump of blue tack on this corner because this thing keeps going whoops and flying across like that, thanks to the tension in here. Maybe if I was to do something with that like that, maybe that would help. I don't know. Now let's see, we've got this sat on there. Now if we change that to, that's continuity, perhaps you could hear that, and if we press it again that should give us diode check. Now let's see what's going on with some of these MOSFETs. So if I go there and there, I get nothing, and if I go there and there, I get nothing. Right, then swap them round and do the same thing again. There and there, I get nothing. I think it might be the coating on the surface is causing that. So let's try and scratch that in a bit more. Oh. Right, so there we are, we've got 0.5 there. Nothing there. See, there we go. Let's just turn them round again. We'll go back into there. And like the 0.5 has become nothing, and the nothing over here is still nothing. Right, let's try this one here then. So we've got there to there, there's our 0.5, so there would be nothing. Right, swap them round. See what I mean? And now 0.5 is nothing. This one is still nothing. So those two, they at least agree with each other. Try and turn in this like that. No, it just goes the other way now. You just can't win, can you? Right, so let's see what's happening with this. So if I try there to there, I get nothing, and there to there, I get nothing. Right, swap them round. There to there, 0.5, there to there, nothing. So that would agree with those two. So perhaps it's not going to be a MOSFET problem then. And then we've got here to here, nothing, to here, nothing. Right, swap them around. Here to here, nothing. Here to here, nothing. Well, that's a bit weird, isn't it? That's not what the others did. Try again. Press harder on there. Oh no, there it is. 0.5. So it is there. So I nearly went chasing our own tails there, and then over there's nothing, but back there, this covering is horrible. 0.5. And then presumably if we go this way, nothing, nothing. Well, surely it's not going to be that this thing is intended to run at 14 volts. That seems somewhat bizarre, doesn't it? I mean, why put a 20 volt battery on it and then only have 14 volt output? That just seems daft, doesn't it? But so they're working. I hate it when this sort of thing happens, because obviously there's 1,000,001, well not 1,000,000, but you know what I mean, there's lots of things on there that could be faulty, and I've got no possible way of finding them. I mean, I've got a diode there that I can test, but I wouldn't have thought that would be a problem. But you never know, so we can do a diode test on that. But I can't believe that that would be the problem. It'd be great if it was. This is just so blooming awkward. Just tries to jump away from you, whatever you do. Right, so we got nothing there as far as we can tell. Let's try and dig it in a bit down there. Alright, so let's swap it round the other way. Yep, and there's our 0.5, 0.6. Hopefully you can see it. I know it's almost out of shot. So that seems to be okay. So we've got 4 MOSFETs that seem to be okay, we've got a diode that seems to be okay. I'm wondering if some of these small wires might be something to do with communication with the battery, so that it knows it's got a genuine battery on it. Or at least it's like a temperature sensor connection on the battery, so that it knows it's connected to the battery and measuring the temperature. So I mean, I don't know, but because some of this might have writing on it that we could read, but we can't because it's got goo over the top of it, so we just can't tell. Well, I'll keep going over this board, looking at it as close as I can, but I mean, I can't see any problem with this board, not so far. So presumably that looks like that's where it takes the plus there, assuming that that is plus. Minus, unfortunately, is underneath, so I can't actually see where it's getting minus from. But no, I just can't see where that minus is connected. It could be there. I could go through on continuity and try and work it out, I guess. Let's try. So what's that one connected to? I thought it just beeped. Oh, this, whatever they put on this is a real pain. Right. So that... well, it doesn't really help. Assuming that that's minus, then that's... no, but that's not minus, is it? That's marked... that's marked plus. So that goes to there. So that's... so that is that, which is that. Right. Right. So that's plus, plus, plus. So this presumably is minus. So that's minus, and then this one is there, and this one is not there. That one doesn't appear to be connected. Oh, there it goes. It's terrible the way this makes connection, isn't it? Right, so it's that is that, which is that. That is that, which presumably is this blue wire over here. So let's see if we can actually get on that blue wire on this side. Oh, crikey. Talk about awkward. Right. So why are you not making a connection there? I thought you were there. No, that's... so that's saying the blue wire is not connected to anything, which I find hard to believe. So it may be yet again an example of this stuff getting in the way. No, I can't get any connection on that blue wire. But it must be connected to something, mustn't it? I can't see where that blue wire is going. Is it there? Oh, it goes to there. So not the other side of the diode. And that goes to there. Yeah, this coating stuff's awful, isn't it? So that is there, which can't be that. That's the other side of it there. But that's not it over there. But surely that has to be minus. That could just be a minus sign there. There's a mark there. So where does that go? So that minus doesn't go. It goes to there. And where does it go after that? To here. So minus goes to here, like that. No, it definitely doesn't go to that blue wire. But you can see it's a job to get a connection by, and then we're right next to each other. So that's everything's down the centre there. He's connected to this, which is the minus. So maybe that is the other end of this plus wire. Perhaps the plus wire goes off to a switch and comes back as a blue wire there. I don't think I'm going to be able to hold these tight enough. Oh yes, so it is. So blue is not blue, it's red really. So red goes off to the switch, comes back as blue. So we get a switch across there, so we're switching that, and that we decided was the positive. So does that mean at some point we're also switching... oh, I don't get this. I'll be switching the positive and the negative. And then of course, what's this other switch for? That one there. Something to do with these. Is that a yellow one? 2 yellow wires. So we've got 2 yellow wires that come back to here. So it's those two. So that wire and that wire. Yeah, I thought I was going to have trouble here. I haven't got enough hands. What a surprise. What do we always have trouble with? Not enough hands. Right. Oh! It won't be so bad, but I've got to press hard, because otherwise that covering will just give me a negative result anyway. Yep, so that switch is switching those 2 yellow wires. Why and what the point of that is, I have no idea. And then we've just got this other odd white wire. So that doesn't make any sense then, does it? I mean, is it possible this thing's designed to run on 14 volts? But it just doesn't seem to make sense. Why would you do that? Well, I'll keep looking over this and see if I can see anything, but I really don't know. I mean, we've got some sort of PCB numbers here, which obviously are fairly meaningless. Looks like 2017-07-29, so that looks like it's 29th of the 7th 2017 for when it was made. We've got another number up there which could be a part number, E206420, followed by HE2000. It's got 94V-0. I've seen that on loads of things, so I don't know what it means, but you see that written on lots of things. So I'm sort of stuck. I mean, it's got a couple of chips which are obviously some sort of, you know, telling all this thing what to do. And it's got some horrible blob thing there. God knows what's under that. I wouldn't even like to hazard a guess. So that is just bizarre, because why have we got 14 volts and not 20 volts? And how can we possibly find out? Right, I know this looks like spaghetti. There's the board, there's the battery, there's the output, yellow and purple, goes to the bulb. So if anything turns on, the bulb will come on. The bulb will come on whether it's 14 volts. If it comes on at 18 volts, there's a chance the bulb might go bang, but we'll worry about that later. This meter is connected at the same point, so whatever voltage we get here, we should be able to measure on there, as long as it doesn't go over 20, because I've got it set to 20. And then I've got these just lying around here, so that I can probe and see if I get any voltage that I want to measure. Now, why am I doing this? There's the switch. That's got tape on it to hold it shut, which means that the red and blue wires are joined. So we should, in theory, be able to find a point that's negative on here, which I think was there. And we should, I think the red, there's our 9, so we're almost 20, 19.77, and if the switch is taped shut, we should get the same here. And there we are again. So it is switched on. So power is going through everything. But this switch isn't pressed. And this is the switch that goes to the two yellow wires on here. The white wire, not sure what that does, but the two yellow wires seem to go to this switch. Now what I want to know is, does this have some sort of secondary control effect? Because obviously if it was just that switch, bulb would be on now, wouldn't it? So bulb is not on now, so what is this doing? It's controlling something, so let's find out together. When we close that, there's our more or less 14 volts and our bulb is on. Let that out, gone. Now the thing is this switch somehow controlling whether the MOSFETs are on or not? That would seem logical to me, because if we say to ourselves, right, MOSFETs are switched off at the moment, so everything is off, and then we say when that is pressed, we switch the MOSFETs on, and it works. But we've got the wrong output. Now that suggests to me that when we switch the MOSFETs on, something isn't right there. At that stage, when we switch them on, something isn't right. Now that is the problem, isn't it? So how do we find out what isn't right? Now, if we look at what we've got with the MOSFETs at the moment, if we take that as minus there, and we go to that point on that MOSFET, we've got, there we've got it. It's so difficult with this covering, but look, there we've got, there's our 19.7, we'll call it 20 volts, so there's our 20 volts. So it's going to there, and so you'd think it would also be going to here. But it's not. I don't seem to have anything at all going to that one. So I have that one. Now, I did read online that sometimes these are connected crosswise, so not here to here, but here to there. So what happens if we go across to that one? My hand's going to get in the way a bit, but no, you see, so we haven't got 19 volts there apparently. So what about this one? But we've got 19 volts there, so we've got 19 volts there, and we've got 19 volts there, so that's interesting. So they have both got 19 volts going to them. Then we've got two terminals. Now it could be gate, drain, source, or it could read gate, drain, source, so I don't know which ones of these is which. So at the moment I'm just going to see what's going on, because like we say, we've got 19 there, so we don't really expect to get, oh, so we've got nothing coming out there, and we've got nothing coming out of there, which seems reasonable. So we've got power there, nothing coming out, because we think it's not being switched. Right, we've got power here, and then if I can get over to that leg over there, nothing there, and this one, nothing there, because nothing's being switched. These ones we've got nothing at. Oh, but we have there, look, we've got 9 volts there apparently. So what if we look at the equivalent spot on this one? Nothing. But we've got 9 volts on that one. And then on that one, we've got nothing. And I just don't know what that means. But what would be interesting to know, wouldn't it, is what happens to these when we press that switch. So if I can somehow press that on there, and this is you whippy, you know, 3 hands job again. Why do I always end up needing 3 hands? Alright, let's just make sure that they're pressed on as tight as I can get them. Right, let's press this trigger. Well, that is barely changing. So what about this one? Press the trigger. No. No, see, but the problem is, am I getting a good connection? So, from here to here, we got 19 volts. When we put the trigger, pull the trigger, we'd got nothing coming out. Now what if we try to go over to this one over here? And I just can't get my hand on it tight. Let's try it there to there. Pull the trigger. 19 volts. So there to there we've got 19 volts. So what about on this one over here? But we only got that 19 volts when we pulled the trigger. So does that mean this one over here is the gate? Well, that one's saying 13.5 volts, so that's not a lot of help. Unless 13.5 volts is what it takes to trigger it. So why no output on this one? So let's try again on this one. Try and push that in as best we can. No, nothing. Try to give that a really good push. Nothing. So now you know as much as I do. We pull the trigger, that one becomes 19, which puts 19 out here. Pull the trigger on this one, this is already 19, nothing happens. I can't see it's got anything to do with which way round the probes are, because it would just read the opposite. So if it wasn't 19, it'd read minus 19. So it would appear we've got nothing. So why have we got nothing there? I don't know if anyone can explain what's going on here. It's just doing my head in. If I put that probe on the minus, so that's the minus connection, and then I go on the plus connection, obviously that's the battery voltage, so that's give or take a little bit 18 volts. Then if I go output to the switch, still 18 volts, back from the switch, still 18 volts, MOSFET there, 18 volts. Now I'm assuming that that's the drain, but it doesn't really matter for this, so that's 18 volts. And if I go over to here, also 18 volts. Now I've got all switches pulled at the moment, so if I go to here, apparently I've got 19.6 volts, and if I go to that one, 13.5. And if I go to this one, basically nothing, and if I go to this one, basically nothing, which is what we've said before. But if we keep following this side, so we say, right, that's our 18 volts, there's our magic 19.6, which I don't understand, and then there's our 13.45, which then goes to this 13.45, which then over here becomes nothing, and there becomes 1. But if I go to the positive wire over here, which is the output to the motor, there's my 13.5 again, that was here. Now this is where I'm completely confused, because if instead I put that on plus, so I'm now on plus, and I can move it over to plus back from the trigger switch to include the trigger switch, so I'm now on plus, and if I come over here, nothing. If I go here, there's our 18 volts. If I go here, there's our 18 volts. Now one of these goes over to here, so I must have 18 volts here, and if I go to here I get 8.4. If I go to there I've got my 18 volts again. So if I go from this plus over to the minus to the motor, 18 volts. So from plus to minus I've got 18 volts. But from minus to plus, I've got 13 volts. I'm completely lost. I mean, if I put this on the plus again, obviously, then we know that that is going to give us our 18 volts. But if I start probing around here, obviously, plus to plus, not going to do anything. If I go to there, I get minus 4, or if I swap these round, obviously that'll be 4. There, 1.8. There's that minus 4 again. There, I've got my 18 again. And there, I've got minus 16. But I mean, I'm sort of up around my 17 and 18 again. So if I turn these round and go that way, I'll lose the minus sign. So there's 16.7, so that's almost 17. There's 17.7. There's 4.3. So there you go. And obviously the 4.3 and the 18-ish or the 17 point something-ish, you take those two away and you end up somewhere around about 13 and a half. So what is going on? Where is this magical 13 and a half appearing from and then ending up here, when from here to here we've got 18 volts, but from here to here we've got 13 volts. Now I don't know if these are called high side and low side, but if they are, then it would appear that plus to minus that way is maybe the low side, I don't know, but that seems to be okay, that's our 18 volts. But minus to plus, which if that's the high side, I don't know, that's different. And I can't work it out. I just cannot work out what these MOSFETs are doing. I tried to lift one corner of this MOSFET and just to lift a leg to test it not connected, and the leg snapped off, so that's completely useless. I'm going to try to make sense of where these different bits connect. I've managed to look up what these MOSFETs are, that's where the two I took off were, and they are an AOD240 I eventually discovered, and they are arranged with pins, gate, drain, there's a little nub of drain there, and then source. So gate, drain, source, and this is more or less this bit how they're arranged on here. In other words, this little bit over here is our red wire and our blue wire, and that goes across to our positive terminal, which is under here. And then when we close the switch, 18 volts goes to red, then it goes to blue, so this becomes plus 18 volts. So that's going to be our plus point. Here and here, those two, and then those two turned on their sides. Now I think those two are the same as those two, but I'm not 100% sure because it's very difficult reading numbers on these, but it looks like they could be the same. And then above it we've got the wire that goes out to the motor, which is there, which is the black one, which is minus, and then this one which I unsoldered for no logical reason I can think of now, but I unsoldered it, and that's going to be the positive one going to the motor. And to make life more simple, I'm just going to put a bit of red on that one and a little bit of red on this, and so these will all be red. Right, so there's our battery terminal coming in, red, switch is pressed, blue. So we know that we've got continuity from the battery holder to the red wire, and then through the switch to the blue wire. So what we want to know is, where does it go next? So if we stay on the blue wire and we touch this, now that will be the drain of the first MOSFET. I'll call that the second MOSFET. I've no idea which one's which, but so we've got, but to the drain of there, the drain of there. And if we look, this would be the source, no connection to that, no connection to that, which would be the gate, no connection to the source there, no connection to the gate there. Now what about these two up here? Not connected to that drain, not connected to that drain. Connected to any of these? No, can't quite get to these, but there. Go through there, there's one, there's the other, so not connected to those. Right, so that's something else that we now know then. So we know that this blue positive now comes out and across and into that drain and into that drain. Now when this switches, it's really got to go out that source, hasn't it? Because it doesn't switch to go through the gate, it switches to go out of the source. So when these switch, we'll get power here. You can't check that at the moment, not with a continuity tester. But so we can go here though, and we can try to work out, where does this go next? So if that's the source over there, then that's it there. So we can go to that, and does it go to any of these? No. No. It goes there. Now where's the same one on this side? The source on this side is that one, so it's there. And does it go to there? No. There, no. It goes to there. So now I don't know if we can still call this plus, but I will just, for the sake of argument, call it plus for the moment. So we know that that comes out here and goes there. And we know that this one comes out here and goes here. Alright. So that's working from this end. Now if we try and do the same with the minus, which is this terminal here, so we go on to the minus, let's try to work out where the minus is connected and see where that goes. Now obviously it's not connected to these because we know that they're already connected to plus, and it can't be connected to these, or at least we don't think it can. And we know it can't be connected to there because that's the output from one of these. But there we've got minus, and there we've got minus. So that would be the source of that one and the source of that one. So it looks like over here, we'll just say it's over here for the sake of argument. So there's our battery minus, or we could call that 0 volts if we want, and that appears to go up here. I'll skip round that one into there. or out of there and back to there, whichever way you want to look at it. And then it also appears to go across to that source there. So that's 0 volts. So here it's our, I don't know if you want to call it minus, ground, whatever you want to call it. So that appears to be minus. So that appears to be minus there. Now, what does that mean? I mean, it looks like it means that the battery voltage can go through here to here, across to here, through there to there, through there to there, and back round to here, which would appear to me to be a short. What do I know? Well, that's what it seems to be doing. So that source is connected to a resistor and a capacitor. So would that be this source here, resistor and a capacitor, and then that source there, resistor and a capacitor, and then where's the source? That one there, we did that one. Right, so every source has got sort of coming off the side, it's got a resistor and a capacitor. Don't know where the end of that goes. So that one comes off there, a resistor, a capacitor, and this source, resistor, capacitor, and then this source, resistor, capacitor. Now we've got this big chunk of capacitors down the middle. Obviously I don't know what they do, and we've got a resistor in the middle there, and I don't know what that does. So we've got a whole load of things I don't know what they do, and then of course this bit becomes so complicated it's ridiculous, because but this obviously is something to do with getting power to the gate. It must be, because none of this will work until this switch on these, well, these two yellow wires, until that's closed, the rest of it doesn't work. So we know that when this closes we get power to the board, but this must power up the gates somehow and turn the thing on. But of course it doesn't really help in terms of this, because it doesn't make any sense, does it? Because we've got the 0 for the battery. How does it ever get to the 0 for the motor? And how does one side of this become the minus side and one side become the plus side if the plus side appears to connect all the way through on both? I've got some MOSFETs for those positions. I've been doing a little bit of tracing out as before, and I could have got this completely wrong, but if we assume that that MOSFET is that one there, so we've got there and there, which is that one, and then we've got here and here, which is that one and that one. It seems to me that if we switch this MOSFET here, then we should end up with plus going to the motor. And if we switch not this one, but this one, then we should end up with minus through there to the motor, or returning back from the motor, whichever way you want to look at it. So it looks to me that if I only put that MOSFET on and that MOSFET on, this should work. It's anybody's guess if that's true, but that's what I'm going to try to do. So I'm going to try to put this MOSFET on and this MOSFET on. It's going to be a problem because I don't really want to use hot air, because I don't trust myself not to melt everything around it. But equally it's going to be very difficult with a soldering iron because this board soaks up heat so fast. But what I try to do, I think, is get some solder onto here so that this is fixed, and then see if I can do the two legs. I think that's the best chance I've got. This is remains of what is probably unleaded solder on here, and it's taken a hell of a long time to try and get it to melt. And try to put, right, so there's some unleaded solder, and some leaded solder, and you saw how quick that melted. And then what we'll try to do is get this MOSFET onto there. And obviously what we like is the legs to sit forward so that you can solder. Oops. A bit like that. So we'd like that to sit there, but we need to get some heat in the bottom here to actually melt it to stick on. So that's where the problem comes in. And try and find something to hold that MOSFET still with. So if I can just get that pressed down onto there, and I think I would like that leg. Oh, it's so difficult to do. I mean, I guess if you're a professional at this sort of thing, then it's easy, but it's not easy for me. And that looks to me about where we want it, but the problem is, can we get this hot enough with the soldering iron to melt the solder? And you can see already, my just being there, it's moving it. Now what we'd like to see is it's sort of floating on the solder. I think the solder has melted. And whether I can press that down or not is another matter. Oh. But I think that's on. But the place it won't be on, of course, is where the legs are. If I try and turn this round, but I think I can probably get to the legs from this side like that, and then that's that one on, and then that one like that. That might not look like an original professional fitting, but I think it's on. Now I've got to do the same, but the problem this time is these stupid wires are in the way. So I've got to somehow get those wires bent over there out of the way, and then hold this still. And I can't see, because if I hold this like this, let's try holding it another way. So I've got to be careful where I grip the board, because there are components on the board and we don't accidentally rip them off. So I'm not going to be able to get much pressure there, I don't think. But you can see that MOSFET then is going to sit there. And we repeat the whole process, but first, let's see, the soldering iron has very little effect on the original solder, and I mean I've taken off most of that solder, but there's some still there and it doesn't want to melt. So we need to get some of this leaded solder onto there, and even this is struggling now because the heat is being sucked out. There you go. now we need to get this to set on there in the right spot and solder in place in the right spot. I've watched people do this on the internet where they manage to hold that with tweezers and then use the soldering iron at the same time. I just can't do that. My hands would shake too much. But I need this to get enough heat into there so that I can push it down and be reasonably confident that it is actually stuck. Oh, there we go, look. So I think... Oh. As soon as I get one end sitting straight, the other end doesn't want to be sitting straight. Oh! I think that's about... No, moved it again. That looks to be about as straight as I'm going to get it. And then just like last time, if we get a little bit of solder onto there, hopefully that's that one leg on. Get a little bit onto there, and then that's that leg on. So hopefully we've now got 2 MOSFETs on. I think we'll use our light bulb on there. I've still got this taped down, so it's jumping off because it's been sitting there for minutes for you, but about 3 weeks for me. But that's still hanging on to there. So this will be the one, I assume, that switches the MOSFETs. That's where we need our light. Right, battery's on, light's on. So all things being equal, when we squeeze this trigger, we should power up these 2 MOSFETs and the bulb should work. And it doesn't. Nothing happens. Sometimes you just can't win. I'm just doing a quick test here. There's the minus connector, there's the plus connector, more or less 18 volts. 18 volts going to the switch, 18 volts back to the switch, 18 volts to the MOSFET, 18 volts to that MOSFET. If this one's got 18 volts and I've put some tape over here on what I assume is the switch for the MOSFETs, then one of these should have output. Now, according to my little picture that I made, it's this one. Nothing. 18 volts there, nothing out, it's not switched. This one, nothing. This one is the one that's supposedly doing the switching. Now if I swap and then I go to the positive over here, then one of these should be the negative. So we should get our 18 volts, which we do. And if it's switched, we would get 18 volts coming out, which we do. So we've got power to there. So it looks like the connection from here to here is working. Because look, here's our 18 volts. There's our 18 volts. There's our 18 volts. And there's our 18 volts. So we're okay on that side, but if we go from the minus across to the plus, there's our 18 volts. But we have got no switching. And obviously if we've got no power there, we're not going to get any power there. So this is not switching. I've put the other two MOSFETs on. It's a bit disappointing. You press the two triggers, nothing happens. And obviously I've no idea why nothing is happening, because in the past we did get bulb light up, just not as bright as we expected. Now with new MOSFETs we don't get anything. As you've seen, even with 4 new MOSFETs put on here, I still can't get this to work. It's just hopeless. But what I did buy, just in case this situation arose, was this. Now this is DC motor drive board, H-bridge, PWM motor controller module, 450 watts, DC, 12 volt, 24 volt, 36 volt, reversing brake. Now what that actually means in reality is that if you connect this to the battery, which I have, so there's one wire, positive wire from the battery, negative wire from the battery, and then here we've got positive, unfortunately in blue, going to a motor, negative wire, a sort of greeny yellow colour, going to the motor, and then over here we've got 1, 2, 3, 4, 5, 6 control wires. Now these control wires, I'm not 100% sure what they do or how they work in this, and you'll see why. If I press this switch, all it does is connect the battery to the board, and the reason I don't leave the battery connected to the board is that when you connect the battery, a little red light comes on, so obviously that would slowly drain the battery. It might take a long while, but it would slowly drain it. So that would be my first switch, main power on. If I press this switch, nothing happens. And what this switch does is it grounds one of the PWM inputs. So in other words, it's a bit like giving it 100% signal instantly. At least that's what I think it's like. Now, I don't really understand at this point how the rest of this works, because in theory we need one wire to make it work so the motor will go in one direction, a different wire, that one there, to make it go in the other direction, which of course we don't want, we only want to go one way, and then finally supposedly we need to trigger this wire and that wire at the same time to stop the motor. But in reality all I've done is connected one ground to one input, and if I press this and hold it, then the power's on, and if I press this one, and you can see that as soon as I take my finger off, the motor is not continuing to spin, it's braking. I mean, that is definitely braking. So I don't really know why it's doing that, but I'm quite happy to let it do that. Now the problem of course is these two switches, they will be okay because we've got two switches just like those connected to the original board, so that's not a problem. Our problem is going to be the size of this board, because this board, as you can see, has got a thick heatsink on it, so it's going to be quite difficult to get this to fit inside the housing with that attached to it. But other than that, it looks as if we could do exactly this, because what would happen is when you pull the handle it would go, so we would have all the functions that we need. That's the board I'm sick to death of. Here's one lot of wires and a trigger, and here there's another lot of wires and a trigger, so they're going to go back onto the handle. But the bit I'm amazed at is this. You can see it's all closed. That's in tight, all okay. Now it is tight fit, I'll be first to admit that, but if I lift that up with a bit of luck, there's the board, there's the battery power coming in, that's where the two battery terminals are going to go. There's the input from the battery, so that has got to reach to here, and the output to the motor, which has only got to go up to about here, so that's dead simple. And then the switches. The only real problem I've got, no heatsink, because there isn't any possibility of fitting the heatsink in that tiny little gap. So that I've got to think on. I've had a little bit more of a play with this, and you can see it's all together okay. If I can get it to pop apart. Those bits are falling apart, but that's what I've done to the heatsink. I've had to cut one side off, that other side off, and I've had to shave it quite dramatically across there and at a slant down there. But it does appear it might work. I don't know for sure, but it looks like it might work. The only thing that worries me is this bare tracks on this side touching this, but that's how it was. The other thing I've done is I've unsoldered the connector here, which unfortunately damaged a couple of the solder points, and I'm going to do the same thing here so I can take this off, because, and I could unsolder that, bend it over, but I don't think I gain a lot with that. But with this, the wiring is going to be a little bit awkward, because the wiring sort of comes down from there, and there seems little point in trying to twist it round into there and screw it when it could just come straight down and in. I'm just extending the two yellow control wires. They come from the white switch up there, and they come round here and round here, and they would have reached to this, but they now have to reach to this end of the circuit board, and they don't. So I'm just extending them. I've just put a join there and a join there, so now I need a join here. And a join here. Those are the ones that switch our motor on and off once the main power to the motor has been switched on and off by these two. Right, there's our wires in there. Now we need one control wire that's got to go all the way over to pick up the terminal, minus or plus, it doesn't matter, but one of them's got to go all the way across to a battery terminal, which is now right over here. So this one, if it's this one or that one, doesn't matter, it is not going to reach. And the other one stops, it's difficult to show you, but it stops behind there. It stops level with these two, because there's the two that go to the motor, so just down there. So one of them's going to reach easily because it's only got to reach to there, but the other one has got to go across. Now I think if I was to put that in there like that, that in there like that, that can go in there like that, now that can go through there. Now we only need enough wire to turn round to reach to there. So this piece could almost be our extension piece, because it looks like if we go as far as, let's say, there, and then this piece come round here and round here and round here, and it needs to reach over to there, and it almost does. So with this little bit of extension on it, I think it will easily. So I think what I'll do is I'll join this onto here and make this my extension piece. Right, what I've done is I've trimmed both ends and just pushed the wires together. I think once some solder is in there, that will be all it needs. Obviously I'll put some heat shrink over the whole thing when it's done, but because these wires are quite thick, it takes quite a bit of heat. You can see even if I move the soldering iron to the underneath, it's not actually melting it. Right, there's my extended wire, so I'm going to put it onto where the battery comes in. So that's just going to go onto there, and then that'll give us a connection to the battery. Right, so this will end up as our switched positive, and this is going to be our negative that's not switched, which is going to go straight to the board, and this will be our switch positive coming back, even though it's blue. It's a bit of a pain with this being blue and that being blue. Right, this is our switched positive going on, so that's going to be the switch positive there. So there's our ground wire, or our negative. Right, now when the switch is pressed with these two wires, negative will come straight from the battery to there, and positive will go from the battery to the switch back to here, and that will switch power on. That power on will not come out to the motor yet until this little bit has done its job at this end, and this is where the two yellow wires come in, and they will close contacts, and that should fire the motor. All we've got to do now is get all this to fit in there. It's a job to get everything where you can see what's going on here, but here's the test motor, there's the battery sort of on. Can't quite hold it on when you've only got half of it there. So there you are. It's working. I had to take off one of the ferrite beads. I think it's just for interference, but it just kept getting in the way. And then these were in this sort of funny little clampy things before, but I've just soldered those on now. So that's the wires that will run down here to the motor, and we've just got that little clamp that holds the wires, and I need to put some heat shrink on here to protect the ends of that. I'm putting some heat shrink on here. This is heat shrink that's got hot melt glue inside it, so once we've got a little bit of that on there, that should be fairly well insulated as a join, and I can just squeeze the end, burn my fingers, and we should be good to go. Right, that's that bit back together again. Let's see if the battery will slide on properly this time, because it was hard work getting it on when we only had half of it. Oh yeah, look at that, that bit's perfect. Holding you free-handed is about the best I can manage. If we keep coming back this way, there's my hand on the trigger. There's the other end. Push the safety trigger forwards. So I think we can say we fixed it.